For our NAE project, we'll be focusing on the NAE challenge of space exploration and what scientific tools and equipment can help explorers. We'll be focusing on data gotten from Mars, and we're going to compare different aspects of the environment on Mars to that of Earth. These aspects include variables such as temperature, radiation level, pressure, and time. And when we compare this to that of Earth to see which is most suitable for human living, we can then determine what suits or how the suit should be made in order to protect its inhabitor and keep them safe, or if no suit can protect them and they should not go outside. And the second part of our code organizes the data we've gotten from Mars and gives daily reports to the user. So for the first part of the program is going to ask the user to select what units of temperature and pressure they're going to input and what the output they want it to be in. If the user doesn't select a unit, a while loop continues to ask them until they do so, and then they enter the value of they're required to enter the value of the temperature and pressure. After this, they have to enter a radiation level between 1 to 5. And if the level they enter isn't between 1 and 5, a while loop continues to ask them until they do so. After this has been done, depending on what the user has selected, what units the user has selected, the different conversions are done, both for the temperature and for the pressure, while the radiation levels remains the same. After this is done, there will be 3 different conditions for each unit conversion that the user has done. And when this is done, a row vector of 3 zeros is created, and depending on which condition is met, the zeros are going to be filled up. If it's the first condition, the first zero is going to be filled with a 1. If it's the second condition that's fulfilled, it's the first 2 columns will be filled with 1s, and if it's the third condition, all the columns will be filled with 1s. And then each vector of each parameter is going to be put into one larger matrix, and then we're going to find the sum of that matrix and find the max of that matrix. And if that max value is not equal to 3, then no suit can protect the user. But if the maximum value is equal to 3, a for loop selects what suit is most suitable to protect the user in the Mars environment. So first of all, the second part of the program is going to load the weather history file, and then it's going to ask the user to input the current time, and the time has to be in between a 24-hour limit, or a while loop will continue to ask the user until they enter a time in between this limit. And the user has to select what time period do they want to analyze, whether it's from the past week, from the past month, or from the beginning. And depending on which is selected, the program will then display the history from that time period. And then a for loop is then going to remove any missing data from the history and put it in a different matrix. And then we're going to the user has to find the time between the sunset and the sunrise from that particular history data, and then they have to find the maximum and minimum of the air temperature, ground temperature, the pressure and radiation, and then find the average of these maximum and minimum values. And then after this, And then the program is going to convert inputted time and time of sunrise and sunset into hours, and then it's going to find the average of the hours between sunrise and sunset and find the difference between them. And with this, it's then going to determine how much time has passed since sunset, or how much time it is till sunset, or it's going to find how much time it has been since sunrise, or how much time it is till sunrise. And then the program is going to produce graphs for the variables we've given before, such as air temperature, ground temperature, pressure, and radiation. So this is the first test case for part 1, and I'm gonna run it and select Celsius, from Celsius to Fahrenheit, and put our temperature, and then from pascals to atmospheres, and then put our pressure with the radiation level of 3, and it gives us to select suit B. And then for test case 2, we are going to select from Fahrenheit to Kelvin, and from atmospheres to torr. With a radiation level of 4, and it tells us not to go outside, that no suit can protect us. And then if we do not select the unit of temperature or unit of pressure, the program gives us an error and asks us to select a unit, and then we put the values in. So for the second part of our program, when we run it, we'll enter a time at 1:56 and pick the time period for the past week, and it produces our values and our graphs. For the graphs for air temperature, for the ground temperature, for the radiation, and for the pressure. And the program, say yes to run the program again, and you put the value outside the limit to see what happens, and it gives us an error. And now we enter a time of 11:25 for the history of the past month, and it gives us the graphs for that time period. So with this code, I think space explorers and scientists, they can use it to help organize all their data, and it will help them to be efficient when selecting what equipment and suits can protect them during the exploration. However, I think one of the limitations are the data is very specific, so there will be other variables that we might need to apply to it, and also the calculations may not always be accurate, so there's still room for improvement. Thank you.